So question 5, suppose that a company has just purchased a new computer for $2,500. The company chooses to depreciate using the straight line method for 5 years. So write a linear function that expresses the book value V of the computer as a function of its age. So we'll start there with that, writing the linear function. So again, a linear function is the form of y equals this mx plus b. So m stands for the change in y or the change in x, where our y is the output, which actually would be the value of the computer. And the input is the number of years that have gone by, so age in years. So what we're picking up on is if it has a straight line method, that means it's going to depreciate equally over 5 years. So if it's 2,500 to start with, if we divide that by 5, that'd tell me how much it depreciates per year. So if we do that, so the 2,500 divided by the 5, so it's going to be depreciating $500 each year. So $500 per year, or we just call it 500. That's going to be our slope. Our y-intercept is our initial. Remember, that's when x is 0. So the y-intercept is going to be when x is 0. That means no years have gone by. What's the value of the computer? Well, it would be $2,500. Not 25,000, but 2,500. So if no years goes by, the value of the computer is still 2,500. So that's going to be the y-intercept. So my function becomes 500x plus 2,500. So actually, I should change that. It should be depreciating by that. So let's rephrase this another way. That is making sense. My depreciation should be negative. So this should be a negative 500. So I should have like 2,500, and I should be subtracting then the 500 per year. So 500 times x would make better sense. So if no years go by, it would still be 2,500. Okay. So the question question part B says, what's the domain of the function found in part A? So the domain is your input values. So notice that the input values it only makes sense to go between 0 and 5. And we're including the 0 and the 5. So that would make sense for the domain, is we're only working our way out to 5 years for that. So then part C is graph the linear function. Since it's depreciating, it should have a downward motion. This looks pretty good here. Notice how the 0 is the 2,500. I don't see another one showing that y-intercept correctly. And it is depreciating by, looks like the scale is going by 500 as well. So 500, 1,000, 1,500, 2,000, 2,500. So if 1 year goes by, that's 2,000. That's looking pretty good as far as the graph goes. That saves the trouble trying to put this to calculator, because I'd have to change my viewing window because of the range values are quite high there. So what's the book value after 4 years? So it's going to lose $500 5 times. So it's going to lose basically 2,000. So it should only be worth like $500 after 4 years. But if we want to actually figure out V of 4 will actually determine our value as well if we actually use our formula. But essentially what we're doing is we're losing 504 times, which is 2,000. So 2,500 minus 500 times 4, which it says 2,000. So 2,500 take away 2,000 should be 500. So after 4 years, the computer will only be worth $500. A lot of times people won't even buy a used computer from you because it's so obsolete. So that question is after how many years would it be worth 1,000? Well, if 1 year goes by, it's gonna be worth 2,000. If another year goes by, it's gonna be worth 1,500. If another year goes by, it's gonna be worth 1,000. So it should be 3 years just by thinking about it. But if I want to use the formula, I should have 2,500 minus this 500x. And I want to know what the output is 1,000. So I want to know how many years it takes for this equation to turn to 1,000. So if I subtract 2,500 on both sides, that's going to give me a negative 500x. So 1,000 subtract 2,500 should give me a negative 1,500. Then if I divide both sides by negative 500, that should give me a 3. So if I divide that by a negative 500, I do get 3 years. So 3 years go by, it should just be worth then $1,000.